All right, good morning. So we'll be we'll be talking about some more about input and output. We'll be talking about working with strings in C++ today. Though first I want to hit on a question that someone asked at the very end of class yesterday. We were talking about floating point numbers and conversions back and forth. And so here is a simple program that sort of is sort of playing with what happens to rounding with floating point numbers. And one of the kind of the fun things about learning programming languages is if you're not sure about something, a good way to sort of answer your own question is to sort of concoct a little experiment to figure out sort of what happens when whether the program outputs one way or another depending on sort of what you set up as the experiment. So here I'm trying to test what happens. 3.14, does that that's a floating point number. What I'm doing here is I'm casting it to an integer. So we haven't seen cast before. We saw implicit casts, like when you assign to a variable, but this parentheses here with int is what we call an explicit cast. And so it's turning this floating point number into an integer with that cast. And so here we're probably thinking, okay, that's whether it rounds up or down, either strategy, this should come out to be 3, right? But for this one, if it's simply truncating down to 3, then we should see 3. But if it's rounding to the nearest, then it might come out as 4, right? So we can kind of like, well, which way should it go? And learn a little bit about C++ through this. And then you might wonder, like, for negative numbers, how does that work? Is it rounding down so that -39 goes to 4, or does it round towards 0, right? So does anyone want to make a guess as to what the output will be of this for this program? Any brave souls?
3, 4, 3, 4.
3, 4, 3, 4. All right, so that would be, and then you mean negatives? Yeah. So that would be like, that's if it rounds sort of to the nearest whole integer would be that strategy. So let's go ahead and see if that's in fact what it does. It's building, and it turns out that it's instead just 3, 3, -3, -3. Okay, so now we've learned that what it's doing is it's rounding. It always rounds towards 0 to the nearest whole integer. Is sort of the algorithm going on inside there. Okay, so just this isn't hugely important, but it's a good thing to know, and more importantly, it's good to know how to write these little example programs to sort of play with an idea and try to poke at what's the language doing in general. Cool. All right, any questions about that? All right. So let's move on here. Actually, it looks like I don't have. Let's do a new project. We're going to learn a little bit about input today. So this is your typical Hello World project. One thing that we haven't yet talked about is this statement here, using namespace standard. So last time we talked about namespaces and how you can, if you want to refer to something in a namespace, you could say something like std::cout, and that lets us refer to this thing called cout, for character output that's in the standard namespace. Sometimes, if you get sick of putting the namespace name there, what you can do instead is sort of do one of these using declarations, and that just brings all of the names from the standard namespace sort of into scope here at the. So you can just use it without the std::, prefix.
So the refer is really just a call, right, to a library that's already named in the namespace, is that right?
The what?
So is the namespace sort of a library, and then the function call that you're calling is, for example, cout?
Yeah, well, so here this is a variable, so cout is a variable that's defined in that, that library, the IOStream library, right? So that's what this pound include is giving us access to that library, but that library is wrapped up in a namespace to prevent sort of name collisions, with the variables in that namespace compared to some variables created somewhere else, okay? And so this using, it's bringing all those variable names, function names, variable names, everything, sort of into scope so we don't have to use this std : in front of the name. Now, so that's convenient, but it's also, let's say you're doing a using of some other namespace as well, you might then get a name clash at that point. So there's a bit of a trade-off, and oftentimes you want to limit the area in which you're doing these usings. So, for example, never do a using in a header file, because then someone else is going to be using that header file. Let's say you're creating a library of your own and giving it to other people. If you put using declarations in your own header files, then now you're sort of polluting the names that the other people are going to see when they include your header file. So it's no big deal to use using inside of your own source files, but header files kind of a no-no. All right. All right. So what I want to do today is a little variation on something we did yesterday, which was we wrote a function to compute the area of a circle. So let's go ahead and write that in again. And it took a radius. Oops. And we're going to multiply, it's 2 pi r, right, is the area of a circle. Wait, I said that wrong. 2r squared. Right, I think that looks right to me. All right, so we have that. But now this time, instead of just sort of fixing the radius to something, let's ask the user, for a radius. They can type it in, and then we'll compute based on that. So I'm going to declare a local variable here for the radius, and then I'm going to ask the user to enter a radius. And then here's the new part. We're going to use cin, which is short for character in. This is also coming from the IOStream library that comes with comes with your C++ compiler. And we're going to use this other operator. So this is the input operator here, the double greater than sign is the input operator. And that's a binary operator. It takes an input stream, and then it takes a variable. It needs to be some kind of L value. That's something we haven't covered yet. But for now, just think of it as you need to put a variable there. It wouldn't make sense to do something like this, 4.5. That would not work, okay? Because you're trying to read it into a location in memory. That's sort of the gist behind the terminology L value, is that there's actually, you want something that has a location in memory to store the data into. And so a temporary like 4 or a literal like 4.5, that's not associated with any memory, whereas the radius variable is. Okay, so it'll store the thing that it reads into the memory for that radius variable. And then we can report the answer here, the area of a circle. And now we can use our function, make a function call. and then tell it to print out a new line, and we're done. Oops. All right. One quick question. So you know how we've talked about expressions, and expressions return values. Now if you had like 40 plus 2, that's going to return the value 42. Now this input operator, this is also an expression, and so it's going to be returning some kind of value. But it's a little funky, so does anyone know what the value gets returned from cin after you've inputted, asked for input and put it in the radius? What is the return value there? Yeah. In this case, so it turns out that it's actually the input stream again. It returns that same cin input stream. And the reason why it does that is that, let's say, instead of just inputting two variables, let's say we had radius 1, radius 2, you can go like this. Okay. And let me put in some parentheses to make this explicit. This operator is left associative, so the parentheses I'm adding in don't matter, but it just helps you see what's happening. So what's happening here is it's going to ask from the input stream for a floating point number and store it in radius 1. The return value of that is going to be the input stream again, and then and then we're going to ask from that same input stream, we're going to ask for another floating point number. Okay, so this is the same as if we wrote okay, so that one line is the same as these two lines. Okay. And if you remember, cout worked the same way. The return value from cout of using the output operator with cout is just, again, the output stream cout. All right, let's get rid of that. I think we're ready to run this now. Oops, I need to build this guy. A little slow.
Your CN is still radius 1. Does that make a difference?
Oh, yes, it does. And in fact, if you can see here, there's a little bug sign there. And it's saying, it's hard to see it, but down here it's saying symbol rad, as in radius, unresolved. Let's see here, what's the right button to push? There we go. Symbol radius 1 could not be resolved. Radius 1 was not declared in this scope. So there's no variable named radius 1, and so it's complaining. We'll save that. Let's try building that again. All right, now we don't have any little bugs running around, so we should be good. Okay, so it's asking for a radius, so let's go with 2. So if we put in 2, we should expect to see something, 2 times 2, 4 times 3, something on the order of 12 something, and indeed 12.5664. Okay, so that's the gist of being able to ask for input. One thing to notice is that there's actually some smarts going on here. So the input stream knows that we're asking for a floating point number, okay, and so it was able to sort of turn the actual. So I typed in 2, but 2 is actually, as I'm typing from the keyboard, that's a character, not a floating point number, right? It's just and if I had typed in like 2. Let's do a slightly different one. let's do like 2.5. 2.5 is really a 3-character sequence, a 2, a decimal point, and a 5, right? But the input stream is smart enough to realize, oh, you're asking for a floating point number. Let's sort of parse and figure out what that character stream looks like, and then pull out the number, or to convert that to a number for you. So there's actually a lot of stuff going on under the hood just in this one line here. So that's kind of cool. All right. Let's move on now to a bit more of a complicated program. It's called frame name. Okay. So the idea here, and this example is meant to demonstrate a bunch of capabilities of the string type in C++. Okay. So what we're going to do is we're going to ask for someone's name, and then we're going to print it back out, but with this with the name framed in these asterisks. Okay, so it's going to we're going to put a border around it. Okay. So the first 3 lines are things that you are fairly familiar with. Here we're just doing a cout, and then we're doing to print out, please enter your name, and then we're saying do a cin. And read, this time instead of a floating point number, we're asking for a string from the user. And again, this is just handled automatically by the input stream. Okay, now here's some more, this is sort of the new stuff now. So here we're declaring a variable of type string, and now we're initializing it. But this time, what's happening over here on the right-hand side is a little bit interesting. We're using a plus operator. And that plus operator is doing string concatenation. Okay, so it's sticking 2 strings together. So the first thing it's going to do is it's going to take this hello string literal and concatenate that to whatever name someone typed in. And then it's going to take the result of that and then add on the exclamation point at the end. Okay. So again, plus is just a binary operator. I think it's left associative, if I remember right. So again, the first thing that's going to happen is that concatenation, and then it's going to do the second concatenation after that to the result. Okay. But the gist of this is that you can sort of forget for the moment what is inside of this highlighted region. The point, though, is that when you want to initialize a string, you can say, okay, string variable name equals, and then on the right-hand side there, you can put any expression at all as long as it returns a string. Okay? And a string or string literal. Okay? Now, one little gotcha with this concatenation operator, let's just change this program a little bit, and you'd hope that this would still work, but no, it doesn't work. Invalid operands of type const char blah and const char blah to binary operator plus. Okay. Now, if you remember from last time, I hinted at that when you've got a string literal, C++ thinks of that as the const character pointer thing, which for the moment you don't really need to worry about. So just sort of interpret that as, okay, you've got a string literal and another string literal, and it doesn't want to plus those together. Okay? So what's going on here is that there's no built-in plus operator on string literals. But what it does have is you can do plus between a string, like one of these string types, and a character literal, or string literal, or two strings, but not 2 string literals. Okay, so this is kind of an annoying gotcha of C++. So for example, this works because I've got an honest-to-goodness string on the right-hand side. I could flip it around, that would work as well. But when you have just 2 plain old string literals, that doesn't work. Okay.
Is there a way around that?
Actually, so yes. What you can do instead is you can actually just, if you have two strings next to each other with no plus operator, then it just, it turns out it'll go ahead and concatenate those together for you. So, so here, for example, let's go ahead and run this guy now. Right, so here you can see the result of doing the framing, except that, of course, I didn't put my name in the middle there, so it just says hello, question, exclamation point. But then if I go ahead and put my name back in, let's do that. We can run it. And there we go. There's what you'd expect from this program. Okay. Right, so we covered this concatenation operator. Okay, let's look at this next line here. There's two things interesting going on. First of all, we're creating another variable here. Okay, so we're creating a variable called spaces. And then this parentheses here means it looks a little bit like a function call, but what we're doing is we're calling something called a constructor. Okay, so all types have constructors, and it's sort of like what they are is it allows you to sort of pass in more information that it might need to create an object. Okay, so in this case, what we're doing is we're passing in a number. Okay, I'll explain this in a second. We're passing in a number and a single character. Notice that we don't have double quotes here. It's just a single quote around, and then this blank thing here is really a space, like as in the space bar. Okay, and so what's happening here is this constructor. If you go and look up in the reference manual for the string class, it'll say, and in fact, if I hover over this, it'll show you that constructor in more gory detail than you'd ever want to know. And but unfortunately, it's just showing you the prototype, what the function looks like. It's not showing you, it's not giving you any explanation, right? So you'd have to go and go online and do a lookup on the reference manual for that. But so what it's doing is it's going to replicate that character sort of as many times as the integer argument, the first thing. So what it's going to do is it's going to create, as many spaces as the same length as this first string. Okay, and we're going to use this to fill in this region here of our framing. Okay, and then this next one, we're creating another variable called stars, and we're going to use that to sort of create this many stars for the frame. Okay. Now the other thing that's going on here is that we've got this dot thing happening. Okay, so that is how this dot operator. If you have like something like an object like greeting, you have a dot. You're going to be accessing data members or methods of that. So you can think of a string as like having like a collection of things inside of it, right? It has a collection of functions that you can access. That in these functions we call methods, okay? And it also has data inside, though oftentimes the data is hidden from us, so we can't actually see it or get to it directly. But instead we're sort of getting at it through these methods, okay? So here there's this function called size that's sort of you can think of it as being inside that object, and we're calling. And then this open close paren that's where the parameters would go. This method has no parameters, okay? So it's just open close paren. So this whole thing will call that function that's part of the string object and return the size. So as we go along, we'll see lots of examples of calling methods on objects. Now, one thing to know is that the string, it's coming from a library, right? It's coming from this string library. Actually, I probably should have. It's probably bad form not to include string here. which is the library that it comes from. The reason why this program worked without that include was that I think the IOStream library already includes string in it, so we got it sort of for free. But yeah, so string isn't a built-in type. It's coming from a library, and it's an object that's defined in those libraries, so it can have methods on it. You can't, for example, do something like this. Naively, you might think that that would work, that, oh, we're creating a string, and then we're calling a method on the string. But this thing here isn't a string, it's a string literal, which means it's this funny const char star thing, which is a built-in. So it doesn't, these built-ins like floats and character pointers and stuff like that don't have methods on them. Okay? Just, All right. Okay, so that explains those lines, those constructor calls. And then here we have a bunch of just simple, cout, calls to cout that you guys have seen before. All right, so that was a whole bunch of stuff all at once. So maybe it's a good point to pause for a second and ask, pause for questions.
So because you made greeting a string, that greeting, for lack of a better terminology, that variable greeting then has its own functions. that
Right.
you can call.
Right,
Size being one of those.
that's right. Yeah.
Okay.
Right, like that example I had below, I was saying this doesn't work, right? But if you instead take that hello and use it to sort of create an honest-to-goodness string, then it works fine, right? So now that's fine because we're taking that string literal, turning it into a real live string, that's an object with functions in it, and then calling the method on that.
So is that the same for ints and floats and everything else?
So ints and floats, those are built-ins, and there's no methods inside of those. So you can't say 42 dot size, that doesn't make any sense.
Okay.
Because it's a built-in. It turns out there isn't a class in the standard library for holding integers. People just use the built-in straight up. And that's because, the built-in sort of number already does sort of everything you'd want it to do. It already does addition and all these things. The reason why we have to have this funny string class that's not a built-in is that the built-in notion of string is so impoverished that and this is kind of coming from the C heritage, that it's sort of, all the interesting stuff that you want to do with a string, it's sort of not there. So in C++, they came along and said, oh, let's build a string, these string objects as a library that give you this more full-fledged functionality. And that's actually a common theme you'll see in C++, is that we've got all these very rich libraries. And so things that you might see as built-in notions in other languages, so for example, like in Python or Perl, strings are like these, the built-in string actually has lots of interesting functionality associated with it. You can do concatenation just with plain old strings in Python, and that works fine. In C++, a lot of that stuff is instead done in a library. Okay, and for the most part, it just works seamlessly. But every now and then, there'll be a little bit funniness where you're sort of seeing the underlying, C heritage pop through. And one of those examples was when we were up here talking about this guy, and we deleted the name there. You couldn't just plus together, two string literals.
So do you view these special variables, the ones that have a class associated with them, oftentimes as matrices that you can operate on then? Do you look at them that way?
Well, not necessarily. So there are matrix libraries out there, and so I've in fact built one. It was one of my specialties back as a master's student way back when, And so those definitely, yeah, those matrix classes acted just like matrices. You could multiply them, add them, multiply them times a scalar, and all kinds of cool stuff like that. And so there, the analogy is perfect, right? But for like a string class, there's a lot of ways that it doesn't act like matrices, right? Like actually saying size of a matrix doesn't really make sense. You'd instead want to ask like numbers of columns or number of rows or things like that, right? So that's where it starts to break down. Yeah, but you can think of it as being a sort of a larger grained chunk of functionality, sort of at a higher level than just things like individual characters or numbers or things like that. All right. Let's see what's next. Okay, let's just take a couple minutes. If you've got your laptop here, cool. If not, maybe once you can get out a pen and paper and try to kind of come up with a solution to this. But what I'd like you to do is try to write a program whose output looks like this, or something. I'll give you the exact specification for a second. But the idea is to output some kind of triangle. It doesn't have to be exactly, like here I've got a right triangle, but you could do whatever kind of triangle you want, just made out of asterisks, and have it be 5 lines long. And as you're doing that, just for fun, you could do this really simply with just a bunch of couts, but try to use like concatenation or some of these string operations to do it. So it's very contrived, but just a little bit of a practice with using these strings and string concatenation. Try to write down a real C++ program. So if you've got your compiler, great. You'll be able to run it. If not, try to do it just as if it would be a real program. So it needs like a main function and stuff like that. So let's just take like 2 minutes, try to jot that down, and then we'll talk about a solution to that. All right, let's go ahead and talk about solutions. If you didn't solve it completely, that's fine, but I just wanted to get your kind of started to think about it. So did anyone have sort of a strategy or kind of a high-level idea about how they wanted to go about doing this? With the caveat that let's have solutions that gratuitously use string concatenation. Or did any of the ladies back there have a idea?
So, like we can start with one star and then concatenate the same string again to it.
Okay, so you've got string. Maybe I'll start out with star here, and then how did you want to put a single asterisk in there?
Yeah.
And so how are you thinking about doing that? Like from a nitty-gritty programming standpoint, like
Star equals and
equals and then in quotes.
star. Yeah.
Great. Like that?
Yeah.
Great. Okay, and then what were you thinking?
Then we can put some loop or as many times we want, and then we can add it
And then we can concatenate it.
concatenated. Yeah.
So we could say star. Actually, let's do star for the first line, and then you could do star concatenated with
Star.
itself, like that. Yeah. Right, that would be one way to do it. Now,
We could store star plus star somewhere else, and then
yeah.
so that.
So maybe we do string star 2 equals star plus star. You mentioned a loop, and we're going to get to loops really soon here.
Okay.
And you're absolutely right that this, in fact, this is getting kind of, repetitive, right? Well, let's say we did star 2 plus star or something like that. And sort of the whole. Go ahead.
Can we do like that also? Like you can have the star character, and then the number of times we wanted to repeat, like that.
We're using a loop.
No,
Yeah.
Not using a loop the way you did it earlier.
Oh, right. So for example, here we could say string, star 5 could be, we could say like 5 and then
Star. Yeah.
star with a single quote there because we're using a single character and then replicating it. Yep. Yeah, so good. So then down here it would do like star 2, star 3, and this is a little bit repetitive on purpose because we're sort of going to be doing looping soon. So we don't have to do things that are so repetitive. That's what computers are really good at, doing repetitive things. All right, so let's go ahead and,
What is that final character?
whoa. Oh, that's me, typo, yeah. That's me trying to hit the save button and accidentally mistyping. And voila, we've got what we expected. Yeah. All right. So that was just a simple example. All right, so now we're going to be jumping into sort of more interesting forms of what's called control flow. So far, the way our program has been executed is sort of one statement at a time, right? So it started at the very first, go to the second, third, it just marches down executing each statement. So now we're going to be looking at ways of branching and doing sort of two different paths. So we'll be learning about if statements, and then we'll also be learning about loops, where you're going to be continually executing a certain group of statements over and over again. Okay? So let's look at our first example here. Let's find needles. Maybe I'll leave it like this. So in this program, we've got this string called, that says there are 2 needles in this haystack with needles. And literally the word needles appears twice in that string. By the way, here we're seeing another constructor for strings. This constructor, where this version of the constructor takes just one big string literal. Okay? And then here, So we initialize str with that long string, and then str2 with just the word needle. And then I'm going to use, here's yet another method on strings called find. Okay, and what this does is it takes some string, and it's going to be looking for that as like a substring within the bigger string. Okay, and it returns the position within the string that it found the substring, or if it's not there, it returns this special value called npos. Okay, which is sort of just sort of signifies that it wasn't there. Okay, that's not the best name. Npos is not a very good name for a variable. Notice how we're accessing npos. It's again this double colon operator. Now you've heard that double colon is how you access things inside of a namespace. String is not a namespace, so you should be kind of thinking to yourself, what's going on here? Okay. Well, it turns out that classes also act a lot like namespaces. Not completely, but in a lot of ways they act in a similar way. Okay, so npos is actually a variable declared within the string class. Okay, and this variable it lives within the class. There's just one of these variables that exists for like this entire program. You can create lots of different strings. There's still only one npos sitting there. Okay, if instead we had written like str dot, there might have been some other data inside of string. We'd use just the single dot to access that per object data. Okay, but here we're accessing sort of a per class data, and so we're using the double colon there. Okay, so we call find. It gives us back a number, which is the position or npos, and then here's the main thing we want to focus on is an if statement. Okay, so in general, your if statement is going to have some kind of expression here in between the parentheses, and that expression needs to evaluate to something that's convertible to true or false, a Boolean. Okay, and if it's true, then the statement inside the if is going to be executed, and if it's false, you're going to skip past the if. Okay. So what happens here is it says, oh, it's not equal to npos, so we must have found a string, and it goes ahead and says, oh, okay, we found the first needle at a particular position. Okay, which is this found guy here. Here we're calling a constructor for integer. I forget why. It's a good question. We'll have to run it with and without this call to the integer constructor. There's not really much difference between calling the integer constructor versus doing a cast integer. So we could have instead written something like that. That would have cast it. Okay. It's maybe slightly better sort of modern C++ form to do it this way though. Okay. Now there's several other, this if statement's a little bit odd in that there's only a single statement in the body of that if. It's more likely that you'll need to execute multiple statements, in which case you can put curly braces around it, and then now you can, put multiple statements.
Could you use curly braces even for one statement? You
can. Yep. You can go ahead and do curly braces with one statement. You can even do curly braces with 0 statements. It's sort of, curly braces can hold 0 or more statements inside. It's fairly typical that 0 or more is the thing to expect in most of these sort of, like parameters. There can be 0 or more parameters to a function, All
right.
Yeah. Great. Okay, so I'll erase that, but maybe I'll leave the curly braces there. Here, this if, I said if the condition is false, it's going to skip to after the if. It's very common that you'll actually want to do something else in the false case, and that's where you use the else clause. So, so here we could say, didn't find a needle. we could write that there. And then what happens down here is pretty much just just running it again. This time we're doing a find for needles instead of needle. That doesn't really matter. And this is a slightly different version of the find function, or the find method, I should say. And we're starting the search one past the end of where the earlier search happened. Okay, so this is going to force us to sort of, instead of keep finding the same needle, this is sort of saying, oh, start further down so that you'll find the second needle. Okay?
And so that +1 will advance it. What does that mean in terms of something I could understand? Like,
Sure. So what's going to happen, so if we look back up at this string here, the positions start out at 0. So T is at position 0, H is at position 1, and so on and so forth. So we should expect that the output of this first statement here, the first find, should be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, something like 14, if I haven't miscounted. Okay, and then the result of the second one should be something on the order of 20 or 30 something in terms of the position. Oh, and so what's happening here with the +1 is like, so +1 means start your search here. And it's not going to find, this, oops, let's undo that. Because it starts here, it's not going to match this part as needle. It's not going to be able to match that. So it's going to keep going, and it's going to find the needle back at the very end. So let's go ahead and run this guy. So indeed, it found the first needle at position 14, and then the second one out at position 44. Okay. So let's step through this. Okay, so let's go into debug mode, so we can actually kind of watch what's happening with the if statement. I'm going to hit the debug button. It's going to put the cursor here is right at the first statement, and now I'm going to tell it to sort of walk through. So remember with the debugger, you can say step into or step over. If I were to say step into, it would dive into the constructor, the actual function that does string construction. And I don't really want to see the details of that. So I'm just going to have it skip past that. I'm going to have it skip past the found. And then here, it's now, notice now that it went inside the if statement, right? So it's executing this cout that's within the if. It really should be highlighting sort of both lines here, but the debugger just knows how to hide one line. It only knows how to do one line at a time, even though it's really, 2 lines here. Now notice as we go to the next thing, it's going to jump over the else clause, right? So it sort of selectively just executed the first branch, but not the second branch.
So would it have gone into the else if you would have hit the step into?
No.
It still would have skipped over.
It still would have skipped over
Because it did the if.
because it did the if.
Okay.
Now, just for fun, let's change this, okay? Change this string so that there aren't any needles. Okay? So let's abort this guy and start it over. Okay, now let's step again. Okay, so it's getting ready to evaluate this, this condition. But if we look over here, we can actually see that the found value is this 18446. I'm pretty sure this is actually what the actual value of npos. You don't really need to care what that value is, but there it is. Okay, and then now let's do a step. Oh, now we're in the else branch, which is what we expected. And indeed, it's going to print out, didn't find a needle. Why didn't it? Hello, console. I was expecting to see it down here, but for some reason, Eclipse is being finicky. Oh, there it is. Oh, that's a good point. So why didn't it print it right then and there as we were on that point? And it waited until I told it said run to completion to the very end, and then it finally printed it out. Does anyone know why the output didn't appear until sort of much later on?
Your return statement? It has
Yeah, so this is the end of the program, but it's actually kind of a subtle thing. It turns out that with the output stream, it does something called buffering. So you keep writing a bunch of stuff to it, and it keeps sort of storing it up in a buffer, and then depending on what you're doing, it may decide to actually, it can sort of decide on its own when it wants to empty the buffer onto the screen, though there's certain things that trigger it to empty the buffer. You can actually, there's a flush function that you can call that says, I want you to really write this all out right now, and that'll take care of that. But most of the time, if you're just doing these couts, then it'll keep buffering these things up. I forget, I think endl might cause it to flush, but yeah, okay. So let's try that. Let's go ahead and do an endl. This will be the last thing we do today. Let's see if it'll flush. We'll do a debug again. Do an experiment here. We're going to go into the else. Yes, it went ahead and flushed it right away because of that endl. Okay. Alrighty, so that's sort of the gist behind if statements. Next time we'll talk about while loops, and dive into some. Let's see, what else do we have coming up? While loops, for loops, and then we're going to be diving into how to work with sort of whole batches of data and being able to store, like sequences of data somewhere, and then be able to do operations on those sequences. Okay. But any last questions about this particular program?
So that str, you call that a construct?
Constructor. So here, what's happening here, so we're creating a variable str of type string, and then this parentheses here is us passing parameters to the constructor for this string. Okay. Now constructors, you should think of them as functions that build things.
Okay.
So in this case, we're building a string. And
so how does that differ from the greetings string?
The greeting one, I think, let's see here. Actually, let's go back. We can go back to that. It was a slightly different constructor that we were calling. That was in frame name, right? So this constructor here, so you can see there's a comma there. So this guy has two parameters to it. So this constructor does something slightly different. It takes a number and a character, and it replicates that character however many times to create a string. Whereas, so this constructor is actually doing something kind of interesting. There's probably a loop inside there that's building out this string. Whereas, like this constructor here, let's just look at this one because it's shorter. This constructor is doing something really simple. It's just simply copying that string literal to create the str2 string.
So could you make that constructor do the same thing as greetings, or is it?
I could. So I mean, if I instead of needle here, I wanted, I could, if I wanted to sort of look for two copies of, of E,
Okay.
right. So this would create a string that looks like that, right?
Okay.
Right. So you can think of it as there's just these two different functions, constructors, for creating strings. Depending on what you need to do, it might be more convenient to use one than the other.
Okay.
All right, any other questions? Great. All right, well, thank you guys. See you again next week.